Okay, day 7, part 1, part 2. So now that I know I've got an input function working on my in computer, what I want to be able to do is find every permutation of our input parameters. Now, our input parameters are just 0 to 4 inclusive, but each phase setting is used exactly once. That makes life quite a lot easier and obviously massively reduces the search space. I'm not going to bother doing permutations. Itatools is a crate that exists, it's external. This is one of the rare times that I can be bothered to use an external crate in Rust. The other way, the really sort of easy way that's not guaranteed to work, or it's not necessarily guaranteed, it's not deterministically going to find all of the options, is you create a set 0 to 4 inclusive, and you just iterate over that set constantly, and you hope that the random order eventually gives you what you want. Or you actually do the work and go and get the permutations and stuff. But in this case, we're just going to say for each permutation in, let's put this, 5 length permutations of the range 0 to 5. So we can see this is the output. It's going to go and do 0, 1, 2, 3, 4, 0, 1, 2, 4, 3, so on and so forth, and give us all the possible options. So whilst we're in here, what we need to do is we need to create amplifier 1 with first input. The first thing it's going to ask for, the phase setting. First input of phase setting, second input of 0. Then create in turn amplifiers 2 to 5 with first input of phase setting and second input of previous amp out. Okay. Which shouldn't be too hard. So let's take a look-see. What, well, let amp 0 be equal to incomp new. Now we're going to take in data as a string. Now this is interesting. Because we do, it's not new, it's from string. Each int computer is going to take, it's going to take its data, its memory bank as a string, an own string, and we need to reset that each time. So the easiest way to do that is just going to be data.clone. So this is going to unfortunately give us a lot of cloning data. And then a box new, and we're going to give it a function, and it's going to take combo pop unwrap. It's going to do this, isn't it? Let mute inputs be a vec of. If we're popping, we're going to swap these round. So the second is going to be 0, and the first one is going to be combo pop unwrap. Right? So this is going to be 0 and phase setting. So when we pop it off, we're going to pop the phase setting and then we're going to pop the 0. And so the function we're going to give it, we're going to assume that we're only going to do this twice. It's just going to do vpop unwrap. And I was missing a bracket. And we haven't got amp comp yet. Cool. So far so good, we'll grab the data in a minute. Then for underscore in 0 to 4 not inclusive. In fact, let's make this inclusive. It's 2 to 5. Let's make it a bit easier. So that's the amplifier number. let mute output equal to amp0. So then we're going to do amp0.run program, which I'm happy about. Can't find value v because it's inputs. And yes, it's okay. Let's do the map in here, x, and we're going to say x.toString. And then you're going to be 0. Okay. Amp0 run. And this isn't amp0, this is amp1. Not that it really matters, because we're only ever going to have one amp at a time. What did I call it? Run instruction. Store load. Run program. Okay. And you need to be mutable, and we're all good. Perfect. This isn't going to do an output. Where does our output come from? Are we guaranteeing it first is this? Facing the program then calls another input instruction, get the input signal, compute the correct output signal and supply it back to the amplifier with an output instruction. So then we want to see, no, so let mute output be amp1, output store, then -1. So we'll take the last value. Okay, and then so for each amplifier we basically do exactly the same. The only difference is now we're not giving it 0. We could condense this, couldn't we? We could take this entire thing, put it down here. For 1 to 5, let's just call you the amplifier. And you're going to be output. Let me output be 0 toString. Okay, what don't you like about this? Expected string found I size. Really? Interesting. Why did I do that? Because presumably, when I do an output, store load, it is literally parsing it as an I size. That is dumb. That's really quite dumb. Presumably I'm going to break day 5 if I change that, but I really should. Yeah, this should not be an I size. This should be just as is. So push, right. Okay. and then that means the output store is going to be a vec of string, and it is, so it can't be a vec of refstir because refstir might change. Like it could be pointing to some memory. We could have multiple output instructions. So output instruction 1 points us to some memory and sticks that in the output, and some other instruction changes that value. So this needs to be self-load mem to owned. So we're basically going to do a copy or a clone. Great, and then this test somewhere here, test, run, load. You need to be 30. I don't know why my keyboard keeps changing. 33 to control. Cool. So day 5 has broken. Let's go quickly sort that. Pause. iSize, unwrap. And then again down here. Cool. Happy now? Cannot move out, so we'll clone it. Lots of clones. Dealing with strings is going to be a bit of a pain. Cool. So, output is going to be assigned to some value that we're going to clone, and cloning one short string, don't care. It's fine. We're not embedded. We're already doing a whole bunch of cloning on this bit of data here anyway. Yeah. So then at the end, so then we want to have max output is going to be usize min. And we're going to say if output is greater than, if output was usize, these outputs can be isizes. So actually that's what we're going to need. Unwrap is greater than max output, then max output. I think you can assign off this. But yeah. For now, let's do the work twice and I'll worry about this later. Yep, and you need to be iSize min. You need to be an iSize I. Okay, and we're going to return max output. So that should be part 1. Just need to go and grab this. And we need to use standard fs read to string and use path. Create paste here. Cool. We're going to do part 1, and it's going to take a ref string so that we don't have to read it again for part 2. And instead of cloning, let's be explicit. Where are you? It's incomp here. We're going to make this to owned. Okay. Why are you unhappy? Inputs does not live long enough. Where does inputs come from? There. Actually means boxed in fun mute string tick static. Interesting. So we have a lifetime problem. How long are we getting to on this stream? Because other than that, this is going to be fine. Well, let's ignore the lifetime problem for now and just do a let's do tests. Smart test. Use super test, and we're going to put test part 1. So we've got a bunch of programs, and we know what their outputs are going to be. Let's test 1. Cool. And we're going to say 43210. That is correct. 1, 2. So then it's 5, 3. That's. Oh, no. Cool. So that's our test setup as well. Now we just have the small problem of the fact we've got does not live long enough. Inputs gets dropped while still borrowed on line 24. The value is captured here. Now, amp is also dropped, so this is a bit odd. So I wonder if I can fix this by going back and giving this an explicit lifetime. So it's going to be a box tick A. Okay, perfect. Yeah, this seems to be the issue we've got. Boxed in 4 tick A. Type box function over tick A IO is function takes I and O, and it's plus tick A. So boxed in mut plus tick A. You're going to be happy with that. Tick A is not introduced. Yeah, that's fine. Incomp has a lifetime of tick A. Okay, and now I suddenly need to do a whole bunch of tick A's. So we're saying that this has a lifetime A. At one point I understood why you needed to do it on both bits, but alas, no more. This is missing a lifetime specifier, so this has a lifetime of tick A, which happens to be fine. And then you're unhappy down here. Cool. Now what do you want? How do you feel about that? Not good. So what are we trying to tell it? we are trying to tell it that this function has a lifetime ticka. However, it's actually not the function we care about, it's inputs we care about. Can I just move you in? Oh, sweet. Can I undo all of my ticks here? Happy? Alright. Test day 7. Failed! Great. How badly? Failures. Oh, we got a panic! We got a panic on line 76. Parse next instruction. Got a parse int error. Interesting. Let's go take a look. Oh, this is going to do so many. I should probably take a look at the actual function it was running and modify it. Do we know where we are? No. Okay. You know what would have been faster? Yeah. It would have been faster to take you out and do that. Okie dokie. Let's step. And then we're going to get to run program. We're going to step in. And from here, I'm going to go into parse next instruction. And then let's see what happens. So the instruction pointer is, can I have access to stuff here? No. Presumably I could access local variables and stuff. I would just need to learn how things work. Oh, that's how things work. It literally set it up there. So instr pointer is 0 and self dot load mem self dot instruction pointer. That is apparently not how you call functions. Alright, let's just index straight in. Right. Well, that doesn't look good. That does not look like what it's supposed to look like at all. Memory has not parsed correctly. Presumably, that's interesting. Oh, yes. I'm giving it a vec of, and I'm giving a whole string. Rust vec string join. Join. It's going to be that I need to put a comma in. Food string, bar string, string list. Right, so it's not collect, it's just join. with comma. Let's get rid of that. That's kind of awkward. Should have seen that coming. Always good to know that you can't write tests. Perfect. Right. Am I actually returning the value from part 1? Yes, I am. Uh-oh. Invalid digit on line 76. Exactly where it just was. The only thing we're running now is day 7, so this is fine. Where have we... Are we on... We're on par's next instruction. Memory is very, very short. Interesting. Oh. I'm an idiot. Perfect, there we go. 46,014. Boom. Thus ends day 7, part 1, part 2.